Okay, welcome to this CVPR panel. So unfortunately, we cannot hold it live, so we'll record the panel and it will be played during the conference. So I suggest that we go around the room and introduce ourselves first. So I'm Nera Holakimi, I'm professor of mechanical science and engineering at University of Illinois and chief scientist and co-founder of Intellinair, a company that is hosting this workshop already the third time in the row. So let's go around. Ribana, maybe you could go ahead.
I can continue. So hi, I'm Ribana Rocha. I'm a professor of remote sensing at the University of Bonn in Germany. And my research focus is in machine learning for agriculture and environmental sciences. And I work on all scales, starting from close range to satellite-based. And I'm a member of the Cluster of Excellence PhenoRob, which is a huge project in Germany that comprises currently more than 100 people working on robotics and phenotyping for sustainable agriculture.
Thank you. Anna, would you go ahead?
Yep, sure. So I'm Anna Chlinkarian. I'm from the University of Sydney. So I'm working at the Australian Centre for Field Robotics. And I worked first as a data scientist in the field of mine operation. And then in 2016, I moved to the agriculture project. And there are two different huge projects, and developing and application machine learning based solutions for big, large industrial tasks is focus of my research since 2011. Yep.
Thank you. Ali, would you go ahead?
Sure. My name is Ali Karimuddini. I'm associate professor in electrical engineering department at North Carolina A&T State University. My research background is in control, autonomy, and robotics. And what I'm doing is developing robotic assisted solutions for smart agriculture, for example, using drones for collecting imagery data and so on, and then processing that information for assessing the crop health and so on.
Good. Kathleen, can we hear you?
Hi, everybody. It's nice to be here. My name is Kathleen Liang. I am the Kellogg Distinguished Professor of Sustainable Agriculture and the Director for Center for Environmental Farming Systems at the North Carolina A&T State University, just like Ali. The center is a three-way partnership with North Carolina A&T State University, North Carolina State University, and the North Carolina Department of Agriculture and Consumer Services. We have over 30 years of experience and founded through the partnership to help farmers to promote and support sustainable practices. By training, I'm an agriculture economist. I do the integrated research, particularly for sustainable farming and the food system issues. Thank you.
Awesome. So Jennifer, so can you wrap up?
I'm just in the background running IT, but I'm Jennifer Hobson, one of the organizers of the workshop and the director of machine learning at Intellinair.
Thank you so much. Thank you all. So let's go ahead and iterate on a few problems that are most likely of interest to all of us as we all work in this challenging and relatively junior growing industry of computational agriculture. So should we go around the room and each of us states what's the motivation for working in this field? What's the particular topic and the big field of research, and what types of results you anticipate getting in the next few years that would matter to the sustainability, to the future of our planet? So who wants to start? Ribana, let's start from you.
Yeah, I can start. So as I said before, I work in data science, and especially in machine learning. And I mean, I think it's clear that there's a huge potential, but I think that there's not only a huge potential in this automation, but also in gaining new insights. And this is also what I work on. So what I find very interesting and motivating is that we can see patterns or relationships in the data that we would have find a hard time, we have a hard time finding just by looking at the data. So I can give you one example. So in Bonn, we have studies with mixed cropping fields where we grow different plants, and we want to know which crops influence positively each other. And with machine learning, we can learn from existing data to simulate promising scenarios. So we do not actually want to automate. This is also good, but we want to gain new insight from this. And so my major motivation is that such algorithms will help us to develop novel and better management strategies so that we can learn something with the help of machine learning. That's from my perspective.
Great. Anna, would you share your experience with this regard?
Yeah, sure. So I think that there are two aspects of my motivation. So first, taking into consideration increasing population and huge demand in agriculture sector, I think, I strongly believe that exactly as you, Ivana, that digitalized agriculture can improve the situation. And also, as a data scientist, I love working in multidisciplinary groups, and agriculture is the field where we have beautiful academics and at the same time industrial experts. And this continuous process of learning from these experts and exploring new world is super exciting for me. That's all.
Thank you. Ali is working with UAVs and more on the robotics side.
Yeah.
What's inspiring for you?
So
it's for me. Oh, sorry.
Ali.
Yep. So as a person with robotic background, I have been motivated to see what technology and robotics can offer to this challenging problem. For example, in one of the recent NSF-funded projects, we are exploring the use of multiple UAVs for collecting aerial imagery data over a farm. And our hypothesis is that using multiple, simpler, cheaper UAVs might work better than a complex UAV. And simply that might be more effective and creating more, let's say it may have less risk and cost for the farmers. Let's consider, for example, a crash, right, that may happen, right? So in that sense, using simpler multiple UAVs would reduce the risk. The challenge, however, here is that the heterogeneity of the data and UAVs creates significant challenge, and then aggregating all these sorts of information and managing these whole assets would be a challenge, and that's what we are working right now on it.
It's a robustness to single point of failure, as they say. So Kathleen, what can you share with us from your experience?
I work with the farmers across the country in all different sizes, different scale, different types of operation. The computational agriculture comes in very, very important, especially for the precision agriculture beyond just the sensoring and the monitoring system, because we have to help farmers to understand the risk and the unpredictable future. Now, most of the policy right now relates to prevention and then solution after responding to the disasters like a drought, wildfire, flood, that kind of thing. The computational agriculture is moving forward to the future view to help farmers to see what might happen in the future and get ahead of the game plan. In our work, we work with the small farmers, particularly who are in limited resource communities, and many are socially disadvantaged farmers with very, very little resources. The kind of a data science, the kind of a technology usually don't get that far to these farmers, so they're falling further behind in terms of finding better ways to improve their operation and management. So I see, especially from all of what you guys mentioned, there are a lot of potential and many opportunities to transfer some of the cutting edge technologies and translate them into user-friendly and cost-effective ways to help all kinds of farmers, small, large, commercial, private, public, that sort of thing, to make better decisions. Thank you.
Thank you. Right. And like getting to your last statement regarding better decisions. So what do you think? How is the big data evolving in agriculture today? Which data will matter most in this predictive analytics in decision making? What comes first? It's the soil condition, is the weather, is the moisture. So who wants to kind of take a lead here?
I mean, if you like, I can
right.
start
Let's
again.
go the same way around the globe.
So what I would say is there's so far not this kind of big data for close range applications, because I mean, on the one side, we need sensor data with a high variability. That means data which captures the variability in the field with different study sites over the time. And so the most difference between when I talk to, for example, to computer vision scientists and to what we do with our kind of application is, I realize, so for us, we do not have one image or one sensor data of the same plant. So the plant cannot grow in a specific way and in another specific way. So I see there a huge challenge when we think about which data we need actually a lot of variability. And what we need is also in situ data, and this is also a challenge because it's hard to get. And I see all my PhD students running around and doing all this in situ measurements. And currently, it starts again. And but we need this to train our models, and we want to have generalizable models. And one thing I also want to mention here, a little bit away from machine learning, is so the data which is really rare and hard to get is survey data, because in PhenoRob, this huge project I mentioned, we look at technology adoption, and for technology adoptions we need to ask people, but it's really hard to get data from them. Either they do not want to give it to us, or they we have no time and money to get the data. So that's my 2 cents on the big data.
So I see. So you have hard time of getting the data that you need, and
Yes.
you think it matters most in the decision making. What about you, Anna? What's going on in your field?
It's interesting. It's interesting because I found us a little bit lucky because nowadays, at least in Australia, more and more farmers started to trust us. And we have different PhD students, lots of different PhD students that go and collect data at their farms. And you know, it's exciting. It's amazing because this new data, this comprehensive new data, will enable us to support farmers to make more informative decision making on management of their systems. And at the same time, I think that, you know, the most important part when you are asking about big data, as a data scientist, I can say that the most important data when you are sensing data, it's acquisition of that ground truth. Because if you create, a model, you will not be able to validate model without having this labeled ground truth data and comparison to that base. Yeah, that's why I think that the most important part is smart data acquisition. And from that point of view, if it's soil data or if it's water, of course it depends on the task. Because, for example, I work in 2 different topics. Yeah, first it's agriculture, precision agriculture. Another it's welfare in livestock production. For example, for cattle behavior, if we want to see if this animal and predict if this animal is healthy or not. Definitely, we need to collect data from the healthy and from the sick animals to compare and to create that data. It depends on the task, of course.
Of course,
Yeah.
it always depends on the task. Ali, from your perspective, in your robotic applications, what data matters most for your optimal decision making? How to use your robots in the field in the context of different tasks? Maybe you bring a few examples.
Right. So right now, what we are working is on using hyperspectral data, multispectral data, or simply kind of RGB data, depending on different applications and different targets that we have in mind. We may collect different data, the different data that we have in mind. But I think we can think a little bit bigger, the data that right now we are collecting and data that is becoming available soon to us. I think we are fortunate to be part of a kind of technology transfer, technology emerging the era that we are observing, let's say, emerging IoT, Internet of Agricultural Things, naming big data analytics and cloud computing. All of these, when they come together, that will help us to take advantage of all these solutions to develop decision support systems that can support us for more informed decisions by the farmers. And then when taking advantage of all these technologies, we can think of collecting data from different states. Let's call it planting to harvesting to even marketing, and then collect at different stages we may have different data that might be needed. And I think IoT solutions and data collections that we do that we may have would help significantly for all these stages.
Kathleen, from the sustainability perspective that you emphasized, which data has mattered most for you?
For me, again, because of my background is agriculture economics, and I work with the farmers from the sustainable and profitable perspective. To me, there are a lot of data available for the production side, the weather, the operation, the kind of input, output using ratios, landscape, that sort of thing. There are tons of information about that, but there are very limited information in the market and the financial return aspect. The prices for a whole different varieties of produce, meat, value-added product, even about where to sell and who's buying what, how much, that's very limited because a lot of those information are proprietary information. The marketing companies, consulting firms, they keep most of the information private. Well, they want to protect the producers, of course, but also to look at the market orientation for different reasons. It is important for farmers to understand how to balance between production and the market venue. Most of the small farms in the United States, 90%, more than 90% of our farmers are categorized as a small family farms. And these farmers are growing different type of things using very small acreage, and they have multiple type of operations. In that sense, the technology is not really catching up to help them to understand the financial outcomes. What is the possibility for them to grow different things, raise different things, and market them in different ways to get a balance for the income perspective.
So you're facing challenging, most likely non-convex optimization problems that are maybe hard. And then like struggling in between different cost functions and weights, how to be chosen to maximize the benefits for everyone and the whole together, right?
Right,
So
and then
go ahead.
especially for the topic that we're talking about here, there's a regenerative perspective about agriculture, because the line of the production and the consumption does not just end at the consumer. There's a huge waste issue from agriculture production to supply chain to consumption, the waste management. That's really critical right now. And the waste goes back to the possibility of energy, regeneration, compost, or other type of usages that we can turn waste into new values to help farmers. And I think, again, those data will be very, very important. Thank you.
Certainly, thank you. And changing topics a little bit, right? So today, global warming is something we're all experiencing very severely through our kind of weather variations, through hot summers and shortage of kind of energy resources to manage the air conditioning and so on. So what is your perspective on global warming, and how do you see the role of agricultural management practices in it? We know that carbon sequestration can matter significantly in this context. And in general, what's your take? Are you in any way involved with it? Ribana, can we start again from you?
Yes, of course. So I think what is clear is that agriculture is affecting climate change, but especially when it comes to the water cycle. So here's also, we just started in Bonn a huge project looking on the effect of agriculture on the water cycle. And the interesting thing is, or the bad thing is, that it's not entirely clear to what extent and how agriculture is affecting the water cycle. And Earth observations do not support the simply dry gets drier and wet gets wetter logic. And existing climate models fail to explain these observed patterns of hydrological change sufficiently. And that was when I heard this, I was really surprised. And so there's still a lot of research necessary to understand how actually agriculture influence and management strategies influence the climate change and global warming. So this is one part I want to say about it. So it's a lot of research, but I think it's clear, but not really how exactly it works. But regarding the role of agricultural management strategies, so I think there are multiple approaches to a more sustainable crop production and multiple aspects where we need to think about. So one is goes in the direction what Ali does, so the intervention, that means converting the sensor data into actual actions in the field. And here the hope is to work to have more targeted actions, so to reduce the negative impact, for example, for pesticides or fertilizers, something like this. So this is some kind of management strategy that we get more targeted. Another is my focus is new field arrangements. So like intercropping or mixed cropping. So plants interact, hopefully in a positive way, with each other. And most likely in future, we will not have this regular rectangular shaped fields anymore. I mean, it's different all over the world, but mainly we have these same patterns everywhere over a large area, but it goes in a direction that we adapt the fields to environmental factors, for example, the soil. And the last thing I want to add is we need to think about the technology adoption and impact. So technology impacts not only the environment, also the landscape, but also the people. And if you change something for one farm, it's different than if you change the same thing for several ones. And so overall, I think we can positively impact global warming in a good way, that we have a positive impact on this with the management strategies. But I need to say that we need to think very comprehensively and about a lot of aspects about I think Kathleen just mentioned already a few things in this direction, but that's what I want to say about it.
Thank you. That's very interesting and very valuable, especially that your projects, like kind of the European projects, are a bit different from the other projects in other countries, and your perspective is definitely very interesting and valuable. Anna, what can you share about your country?
Oh, so first of all, I think that it's a little bit cyclic behavior. So climate change impacts farmer, and farmer impacts the climate environment. Yeah. So from what I'm doing, actually we have autonomous platform. It's exactly targeting precision agriculture. We have ground-based platforms, autonomous platforms, and they go collect data from crops. Yeah. And what we are trying to do, we want to create decision-making tools that say that how much nitrogen, for example, how much fertilizer should be applied for specific crop. By optimizing this, I think that we will optimize impact of these fertilizer applications. Yeah, different. So honestly, I can't say too much about this field, but my understanding is that collecting data, like looking and learning what happens by impact of climate on farmers, help farmers to make more informative decision making, and then how to optimize using this decision making, how to optimize their impact on the environment. That's you. That's it.
Yeah, sure. You presented the cycle actually very well, right? So, Ali, what can you say, since you're involving the technology that's on the other end? We know how much operating the vehicles causes damage from the perspective of kind of climate change and global warming. So, what's your perspective on the management practices, how they could be organized, optimized to have the minimal damage to our environment in that sense?
Well, I think technology would reduce the damage to some degrees. Let's say before starting using machines all over the farm, if we can, let's say, using UAVs flying over the farm, for example, and identifying the problem spots and only starting treating a particular spot with a sort of optimized treatment plan or whatever. So I think it's going to be reduce the negative impacts on the farm. And that's one aspect that the technology may help on, let's say, treatments, or even, let's say, fruit picking and so on and so forth. So these are all sort of technology things that we can think that can be improved efficiency. One thing that is important here is that the climate, the agriculture sector contributing to the let's say emissions to some degree, but it is very difficult to reduce the impact of emission from the agricultural sector. So every improvement, every efficiency, every practice that we can do to improve the efficiency of the farm management would be really of great value in that sense. Another thing that we can think of is beyond the use of the technologies in the farm, also using data to kind of having more informed decision and planning and preparations for the impacts of the climate, sort of climate aware planning and preparations. And then that also is another piece that we can think of beside the on-site use of technology. Go one step before that and see how the use of data can help to prepare to adapt to the climate change that is happening, and the historical data that we can think to be used part of that decision making. I think that's one way of adopting and being resilient to the impact of the climate.
Thank you, Kathleen. Your perspective from the sustainability research point of view that you're leading. So what would be your final comment on this question?
Global warming influences everybody, whether it's agriculture, manufacturing, retail, everywhere in the ecosystem. Now, something about global warming that changes agriculture perspective, it helps farmers to think carefully before they start operating what kind of input they will engage, what kind of operation style they will use. There are new ways of thinking and new ways of doing businesses, new product lines being developed to respond to the threat of global warming on our ecosystem, like a methane digester, the innovative type, and then the biochar, and then also carbon credit that many states here have applied so far. And there are ways to deal with the issue, but the fundamental challenge is overall the labor and the balance between our behavior and people's preferences. It's hard to change individual or household behavior overnight. We all know global warming is the reality, and it is a problem that we will have to deal with right now. Otherwise, we will never solve this problem. But we really have to engage everybody, producers, and then policymakers and other type of people working in the domain to deal with the fundamental issue is how we change the way we think, with the way we do business, and then how we define our preferences over different kind of commodities. Once we get the overall domain defined and get everybody on the same page, we should be able to achieve our goal. But it takes a whole world to work together, not just the farmers, all of us.
I agree with you. So with that respect, I want to ask another question, which is also critically important, right? Soil is something that matters very much in sustainability, in feeding the world. So soil is the core. And recently, there is a global movement launched by Sadhguru, who is a yogi, mystic, and visionary that's called Save the Soil. So he's marching all over the globe to raise awareness about it, as 52% of our agricultural soils are already degraded. Have you heard of that movement? What's your thinking on it? Or you haven't heard? So just your take on the soil and the perspective of how to save it. Ribana?
I mean, I have heard about it, but not that specific initiative. But I mean, yes, the thing is, I think there's, I mean, I cannot really say something about the specific initiative, but I heard about several ones, and I think it's good. Especially what I see is happening at the moment, that young people care. They start caring about what is happening in not only in agriculture, and everything what's related to climate change. So they really want to change something, and it's good that all generations and all kind of people, let it be from school or researchers or professors, they go and they inform. And also I see this as a huge part of us, and a task which we need to fulfill, because we need not only to do research for our own and to keep our results, and not only to tell them other researchers. So we need to disseminate, we need to go out and tell everybody about it. That is understandable to everybody. So I like such initiatives, and I think it's a good thing to do, and that's the way to go to raise awareness.
This is one of the problems that's a global problem and requires global awareness, global teams to address it from multiple perspectives, and to make sure everybody's aware to do their job, to play their role in this. Who wants to talk on it? If you have any information, any news. I just have a postdoc in my group who is very closely following the movement, and we all the time hear from him about it. That's why he's one of the big supporters of it. That's why the question just came to my mind like that. Ali, you have something to say, Anna? Who wants to go first?
I just want to say that regarding soil, we have lots of different sensors, that sensing the soil, learning about the soil, and I think that it just came to my mind that we need to learn how climate change impact the soil, and how these changes impact, for example, if we work in the livestock production, how these changes impact on pasture, because this connection will impact animals, and the huge sector of agriculture. So that's why I think that as scientists, of course, we need to learn and to be prepared for the worst scenario. But at the same time, as a people, as humans, of course, we need to save our planet. Let's say, big words, to save our planet, and we need to be very careful with our actions and what we are doing.
Exactly, that's like kind of a responsibility already, almost on a social responsibility level. Ali, you want to add something?
So I leave the perhaps a more in-depth kind of answer to the question that you were raising to soil scientists. But from technology perspective, yes, there are solutions. Let's say different sensors to measure and improve the practices and so on and so forth. But what I was hearing in the panel, and I think it was an accurate statement, that the technology solutions can improve slightly or whatever, some solutions, but the problem is much bigger than that, and really requires multi-sector, cross-sectoral, global approach to address the problem. And I'm not going to be promising or over-promising that the technology can address the problem, can be part of the solution, but not the whole solution. So I think we need more holistic approach to address such kind of problems.
Sure. Kathleen, anything to add?
I totally agree with my colleagues and their comments. We have to be cautious, and this is an initiative I have not heard about, and I'm not familiar about the initiative itself. But I think the general approach is we have to look at the issue in different areas, facing different type of challenges, but triggered by the same effect. That's something we all have to be very careful. There's no one size fits all solution. No matter what technology, what data, what kind of a scenario we want to model, the model is still limited information with a limited output. However, we could collaborate and share information and talk to different people in different parts of the world, and then see how they see things differently and how they do things differently. There are always trade-offs, whether it's from social, economic, or environmental perspective. We choose something, and then we will lose something. That's just a natural way of reaching the balance. So from whether it's for value proposition or for the application of certain type of decisions or certain type of technology to help labor, we just have to be careful under what domain and what assumptions we make to move forward with any improvement. Because I think somebody mentioned earlier, any improvement can also hinder the development of new ideas and new opportunities from different aspects.
Thank you, Kathleen. So just for the sake of keeping us on time, so we're almost 50 minutes into the hour, I'll just ask one last question. Say, if you were in a position with power, say if you were in Washington, D.C., in one of the federal government agencies, or in EU, or in Australian government, what's the one thing that you would do on day one to address some of the challenges that worry, for example, today's farmers as they're trying to grow more food on the same land? What type of decisions you would take in terms of funding certain initiatives, in terms of reorganizing the retail industry or something? If you had all the power, what would be your first move, Ribana?
That's a super difficult question. And actually, the first thing I would do is I would think about which experts are needed, and I would like to bring them on one table. Because as I said before, if you do something, it influences something else. And even if you want to do something really good, it might be really bad for in another place. So, and I think that I could, even if I had all the power, I would not be able, or I would not be willing to make decisions what influences other people. I don't know, I would call for a lot of experts and let them think together, because there are so many aspects, and we need to take into account many aspects, and they need to be weighted, and we need experts in decision making, and also farmers. So on all levels, we would need people. I mean, that's a maybe not a satisfying answer, but that's what I would do.
That's a
I
great
would like
answer, actually. Anna, what would you do?
talk to each
That's why I'm
other.
not working in government. That's why I'm not taking this position. Yeah, but to be serious, I think that we need to be like create more open relationship between scientists, between different countries, because we need to learn what decisions are made in different countries, learn from them, and bring this everything together. As Catherine and every one of you mentioned, that we need to be together to deal with this huge problem about climate change, about this global warming, and of course support our farmers, support as much as we can, because it depends, because if they not succeed, we will not succeed. People will struggle. Yeah, I don't know.
So you, Ali, what would you do?
So I think let's start with this fact that data is going to be enabler. So in that sense, assisting with developing and kind of collecting large public data sets from different stages, from planting to marketing and supply chain and so whatever. So and then at the different levels, locally, statewide, and then nationally, globally. So these are going to be something that everybody is going to be benefited. So that's one idea that I think would be good to advocate for. And then the other thing here is that the cost of innovation would be quite high, especially for the agriculture, when we think that it is the benefit margin might be slightly lower, and that makes it quite less agile in adopting technology and innovative solutions, and so on. So if the government can help the farmers and so on to adopt technology and co-share the costs of adopting the innovative technologies and solutions, that would be something that we can make the whole farming system more agile in adopting new solutions. And I think that would be another part.
Kathleen, if you had the power to take decisions, what would you do the first thing?
Well, I've been trying for that for years, and Ali knows how much grant I receive from USDA every year. I do have a direct connection with different levels of policymakers, but if I really work for them in Washington, D.C., the first day I will do is to bring some young people with me to visit those representatives, delegates, staff members, because I really want to encourage our government to invest more on young people's education, training, and demonstration to boost up their faith in our agriculture and the food systems. What we're lacking right now is the farmers getting older, and we're losing a lot of farmers, a lot of farmland every year. Now, that's not a good sign if we really want to feed more people and then still deal with the climate change variations. Farming is our foundation for our health, our community, and our future. So that's what I will do, is to bring young people with me and visit those representatives, the policymakers in DC area, and let them know how we could help young people to understand agriculture is not just about playing with the soil. A lot of people still think about agriculture is just in the production, the very basic production level. But look at our panel today. Everybody is outstanding scholars, and you all have passion and a commitment to work with a better future for agriculture and the food systems. You are all wonderful role models for our young people, and our policymakers need to appreciate that, making a better decision to invest more in our future generations' education. Thank you.
Thank you all. And if I had all the power to take any decision, I think I would create as many as possible experimental research farms where we could rigorously test and validate different algorithms over at least 2-3 years of time span to understand how all that machine learning works rigorously and what do we get out of every experiment by engaging a farmer, a customer, a consumer, a supply chain expert, and so on. If we had all the opportunities for rigorous research, most likely we would be able to push everything forward much faster to catch up with the global warming damages and everything. I want to thank all of you for your participation, involvement. I know we involved different time zones. When Anna joined us, she had dark background. Now she has light, so the sun came up in Australia. Thank you for being up 6 a.m. And actually, in my location, it's 1 a.m. now. Thank you for all your wonderful insights, and I hope this panel will be well listened to in the conference